Seasons are the result of the Earth's axis being tilted 23.5 degrees relative to its plane of orbit around the Sun. In temperate and polar regions, the seasons are marked by changes in the intensity of the sunlight that reaches the Earth's surface. Because of this tilt, the Northern Hemisphere experiences more direct sunlight during May, June and July as the hemisphere faces the Sun. The Sun reaches its highest point on the 21st of June, the summer solstice. However, due to seasonal lag, a phenomenon whereby the maximum average air temperature is delayed until sometime after the summer solstice, July and August are the warmest months in the Northern Hemisphere. This also applies to the minimum temperature being delayed until sometime after the winter solstice of the 21st of December, with February usually being the coldest month. Seasonal lag is largely caused by the presence of large amounts of water, which due to its high specific heat capacity takes a longer time to warm up in spring and longer to cool down in the autumn. The heating of the sun changes with the seasons, and that changes the whole pattern of climate, pressure systems and precipitation. Here on this world map, you can see the air rising at the equator, then moving towards about 30 degrees north and south of the equator, where it sinks to form a big circulating pattern of air called the Hadley cell. The Intertropical Convergence zone, Itcz, occurs where the air converges at points on the Earth's surface, experiencing the greatest solar radiation. All along the Itcz, the purple line on the chart, the air is coming together and rising up through the atmosphere, creating the equatorial trough of low pressure associated with frequent heavy thunderstorms. Here in this satellite image, we can easily see the Intertropical Convergence zone outlined by the proliferation of cumulonimbus clouds and intense thunderstorms. Starting in January, the Itcz is mostly south of the equator, but as we move into the summer, the Itcz shifts north because the sun's heat is also shifting to the north. By the summer solstice on the 21st of June, the Itcz is mostly north of the equator. Also notice that the Hadley cells and polar fronts have also shifted north. As we progress into winter time, the sun's heat pulls the Itcz, the Hadley cells and the polar fronts back south again. By superimposing the predominant pressure systems on the chart and focusing on the North Atlantic and Northern Europe, we can see how the Azores high intensifies in the summer, whereas the low pressure to the north and associated jet streams and frontal systems weaken, giving us the milder, warmer, sometimes even sunny weather with fewer of those Atlantic storms mostly associated with the winter months. The most important control over the climate characteristics of the marine west coast, including Ireland, is its west coast location in the mid-latitudes. Here, maritime polar air masses are constantly coming ashore in southwesterly airstreams, bringing mild temperatures and high humidity. Because of the influence of the Gulf Stream, particularly the North Atlantic Drift, Ireland is much warmer than other countries that share its latitude. The Gulf Stream also ensures that the Irish coastline remains ice-free throughout the winter.